Good morning all. I hope that you've had a good night's rest and are ready to do this algebra again today. And yesterday we finished up section 3, so be aware that tomorrow you're going to have a quiz on sections 1 to 3. You are allowed to work together on that. It's more to see what you learned and make sure that you're understanding things. So you'll be able to do that tomorrow. So the assignment that goes with today's concept, as well as the assignment that goes with Friday's concept, they're both in the same section, divided up into 2 parts. Both of those will be due on Monday, so you've got quite a bit of time to work on that. So I would suggest after watching this video that you go right into making sure your notes and all are together for sections 1 to 3, and I'll try to give a little bit of helps for those that put questions on the subsequent assignments for those that need it. Okay? All right, so let's just jump in on properties of logarithms. We were talking about what logarithms were, but there are ways to simplify problems that have multiple logarithms in them. So the properties that go with logarithms come from the idea that their origins are in exponents. So they behave very similarly to exponents, but it's a matter of getting your head around these basically 3 basic properties having to do with when you've got a product of numbers, or when you've got a quotient of numbers, or whether you've got a power of numbers. So just so you kind of get an idea, I am going to show you a proof of why this first one works, or a kind of a skeleton of a proof. Just so you have an idea, these things didn't come randomly, but they are something that you need to be able to learn and apply. So let's take a look at why this product property works. Okay, so we have the product property where you've got log base b of m times n can be rewritten as log base b of m plus log base b of n. It will show you why it's useful very shortly, but for right now I want to show you why it works. Okay, so we're going to start off by looking at this side and assigning a value of x for this part and a value of y for this part. Okay, so in order to make this look like this, we need to add x plus y in a second. Okay, or keep in mind that this is x plus y. Here we have rewritten this logarithm function in terms of its exponential form. B to the x equals m. B to the y equals n. Okay, so if I multiply m times n, I'm still on this part, multiplying m times n, what I have is b to the x times b to the y. Okay, so far hopefully makes sense. We rewrote this, multiplied m times n because I'm trying to make things look like this. B to the x plus y because that's your designated rule for exponents. You've got like bases, you add exponents. So if I'm looking at that as being a fact, if I take the logarithm form of this, log base b of m times n equals x plus y. Okay, it's just taking exponential form and making it into logarithm form. Okay, log base b of m times n equals x plus y. X plus y is this, just like I pointed out a minute ago. So here all of a sudden we have gone from setting up some parameters, going down through, and then ending up with the property, and everything was done with our formerly known properties and that we've had from your math before. I'm not going to go through and do this for all of them, but just so that you know that these come from somewhere. So now let's jump into the important part of how to apply them and why they're important. So when you're going to simplify a logarithm, okay, there's a couple different things you could do. You could just say 4 to what power equals 32 and go with that, but that could get into some trickiness, but we can use the properties of logarithms to make it a lot simpler. So I want to have this kind of up here so we can look. This is a subtraction, so it fits this pattern. So we can rewrite it as log base 4 of 32 over 2. That's going to be super helpful. Okay, once again, here's our property. Log base 4 of 32 over 4. The subtraction looks like a division when we think about it on logarithms, which really, if you think about it, it's kind of like the exponents when you have a exponential expressions. So you've got that going for you. 32 divided by 2 is 16, as you know. So 4 to what power equals 16? Wait, where did the x come from? Some of you are thinking that right now. The x is just, since I need to evaluate this, and the easiest way to evaluate this is to you're finding out what goes here. So in algebra, anytime you have a missing piece, we can just slip in a variable, especially if it makes it easier to understand. So 4 to whatever that power is equals 16. So my answer is 2 on that problem. So here your simplifying rules make this problem doable by hand very nicely, very easily, because for finding the power of 4 that gives you 32 could be done. It just takes a lot longer because these rules come out to be very nice for us. Okay, let's look at another one. Okay, simplifying this one. This one may not simplify down to nothing, but we can use our rules on it. Okay, oh, I don't want that all to be shown right there. Let's do this. Okay, pull up our rules. I have 6 log base 2 of x, 5 log base 2 of y. This is log, not 51. 5 log base 2 of y. And so when we look at this, we've got a couple things happening here. First of all, I have this number times a logarithm. Where do we see that pattern? That's in the power property. A number times a logarithm. So what can happen is this number that's out front can be brought up as an exponent for whatever it is that's here. So this number out front gets brought up as an exponent here. This 5 out front gets brought up as an exponent like this. Okay, then we have the plus. Okay, here's our plus. So if you keep this little list handy, it's really super helpful in simplifying these things. So here's the plus. So what that means, because you have like bases, is you can consolidate it down into one thing. Log base b of m times m. Log base 2 of x to the 6th times y to the 5th. And they go together. Notice I put parentheses around because you're taking the log of both of them, not just the log of one of the two things. Okay, so these 3 properties using to help to simplify. Okay, simplify means you're bringing it all together, or even to solve like you did in the last one. So the properties can be used for both of those purposes. Okay, writing as a single logarithm is another way of saying simplify. So what we want to do, we want to apply our properties. Always think about getting rid of the powers first. You know how we used to have PEMDAS, and PEMDAS still applies. If we think about our properties and we think about our powers first, looking for anything that's out front that can be brought up, that might be helpful to you. There's nothing out front for these, so we don't need to use the power property. There's no subtractions, so we don't have a quotient property, but we do have a plus. So we can do 5x over 3x, or 5x times 3x. Sorry, here we go. 5x times 3x, because those are in those two spots. And then you can simplify this. So we have log base 4 of 15x squared, and that's brought down into one single logarithm with nothing out front. And that's what we were looking for, one single logarithm with nothing out front when it says to simplify, or we simplify as much as possible. If you have different bases, that's a whole different issue that we're not going to get to necessarily today. Okay, so we have this. Let's take a look at this one. We've got our properties. Oops, not those properties, this one. I'm going to pull this over here. You can see it. Okay, so 2 log base 4 of 6. Oh, there's a number out front here. So we need to apply this property first. Always look for these first. So n log base b of m. So we need to drag that 2, that n goes up as an exponent for the number. There's none of them here, so we're just going to do this first. 2 comes up here. Then what we can do is simplify a little bit. Okay, 6 squared, you can, if you have anything that can simplify at that point, you can. Sometimes you'll have a situation where you have a variable, so there's nothing more that you can do with it, but if there's a number there and you can simplify it, go ahead and do that. We then have this minus. Okay, so you're matching up what it looks like. So the minus means that you have log base 4 of 36 over 9. Fits this pattern right here. Simplify this. 36 divided by 9 is 4. So log base 4 of 4. So this is really 4 to what power equals 4, which is a 1. 4 to the first power equals 4. So our answer, this is a really, really strange looking 1, but it is in fact just 1. All right. Now the reverse of that is expanding the logarithm, which can also be useful in some contexts. So we need to get good at this. Okay, let's bring our properties back over here so we can take a look at them and have them handy. Okay, so on something like this. All right, well, we have an entire fraction to deal with. It's all together, so we're going to look at the quotient property and bring it out this way rather than going from this one to this one. So we're going to turn that into a minus. A fraction bar kind of looks like a minus. I hate to do things just like that, but it's a little trick that's helpful. So here we have a log. Remember, there's a hidden base 10 here if we don't have a base on it, so we can just remember that. So we have 4x minus log of y. That's our pattern. The minus comes from the fact that you've got this quotient here. Then this one's as simplified as it can get, but if you look at just this piece, we have a product. We have a 4 and we have a y. So I can break that down into log of 4 and log of x. And then log of 4 can get broken down. Wait a minute, it doesn't look like it can get broken down. Look for hidden squares. Okay, this 4 is really a 2 times 2, which is 2 squared. Okay, this one's done, but 4 is really 2 squared. When you find that hidden power, this is an exponent. Yes, Mrs. Dowdy, yes, it is an exponent. Yeah, it's an exponent, but that means that now you can use the power property and bring it out front. Okay, so in this problem, you have all this that came right from this. This is the fully expanded version of what this looks like. And this could be helpful in some instances, but if the directions say to simplify, you're taking something like this and breaking it down so that you get a single logarithm. But if you have something like this and it says expand, you're taking the rules and you're running them the other direction until you have it brought out as much as possible. Let's look at a couple more expansions. All right, we have this one. So once again, we have a quotient property happening. So we have a divided by, which turns into a minus with the same base. This has a base of 9. So let's take a look at that. Oops, not that one. I just skipped to the wrong one. There we go. We have our base of 9, so we take x to the 4th minus 729 with the logarithms. Okay, because the division, the quotient property does that. Now, we have a couple things happening. One of the things is that this can be simplified. You're trying to find 9 to what power equals 729. Okay, if we're going to take this, I could have used a different variable. I could have used something different. This is not the same x as this, but just in the interest of trying to find out what this is simplified, you're trying to find 9 to what power is 729. And if you were to go through, simplest way to do that, okay, because we're doing that is 9 times 9, which we know is 81, times 9. There's 729. Ah, there's 1, 2, 3 of them. So it's the third power. So that means that this part right here is just a 3. This part's a 3. This part, the 4 comes round front. Okay, so this part's a 3. This part, this 4, is a power. And to rewrite it, you bring it round to the front of the logarithm. And then from there, that is all you can do with that one. I don't care that this is 2 squared because it's not, you're not taking the log of it. Okay, you're just done with it at that point. The only time you care if it's a squared or a cubed or a power or anything like that, or if it can be broken down, is if it's on this side of the logarithm, because you're taking the log of it. This just means you're multiplying 4 times the answer that somebody would have gotten. Okay, I know that this is a lot to take in. This might be something that you have to go back over a few times and have your assignment in front of you, maybe when you look back over that on Friday, and do that. Okay. All right, so here we have a couple more, almost done. This one's very, very interesting. A lot going on in this problem. It looks very benign, but there's a lot going on in this problem. First, we have the quotient property, which we should be getting used to by now. Log base 3 of 250 minus log base 3 of 37. Okay. This one right here, 37, is not factorable. This one is pretty much done. This one, though, gets to be very, very interesting because this thing can get factored. This 250 is really 2 times 125. Well, why 125? Why is that interesting? That's interesting because 125 is a power. 2, there's only 1 2. If you were to do like a factor tree on this, there's only 1 2. So I can bring out a 2, and I can break that down because it's a product. I can break it down into a plus. Let me bring this back up. Okay, here's our product property right here. 2 times 125, so you'd have log of the 2 and log of the 125 on that. But what did I do? I changed this into 5 cubed because 125 is 5 times 5 times 5. That's why that looks different. 5 cubed is 125, so right in the same step, plus the 125, the log of the 125. But what happens because you have an exponent here is you have one more step to do, and you can bring that thing around to the front like that. So your final answer on this one, log base 3 of 2 plus 3 times log base 3 of 5 minus 3 minus log base 3 of 37. So all of these, this is what came from this. All right, and these things, you can't put this into your calculator to evaluate. We haven't gotten all the tools to figure out those things yet, but these are your different pieces on that. Okay, one more. This is a product and a power. Now I said look for powers first, but think about this. I can't bring this 5 down yet because this 5 does not apply to the whole entire piece here. The 5 only applies to the x. So we have to keep in mind that this is a product first before we can bring that 5 down front. So this is log base 3 of 9 because of the product property right here. 9 times 5x, 9 times x to the 5th, 9 and x to the 5th, 9 and x to the 5th. Then you can take this one and bring the 5 down front because the 5 is applying only to this x. But you're also asking yourself 3 to what power equals 9. So that can turn into a 2. Okay, so anything that can be evaluated should be evaluated. These technically could, but it would, if it doesn't come out even, I'm not expecting that of you. But this one, 3 to the second power equals 9. So this one's a 2. This one, the 5 can get dragged down in front. And so this would be the expanded form of this number. All right, that's it for today. Get your things together so that you can be ready for your quiz tomorrow on sections 1 to 3. Make sure you've turned in the assignment and give me any questions that you might have. And that would be it. This assignment, be prepared to work on that on Friday, and I'll be expanding this lesson and finishing up about the properties of logarithms. I think this is enough for you to try to digest for the day. All right, God bless you. Have a great day.